You're probably familiar with the gradient, but I'm going to do one example, which is one of Griffith's problems, problem 112, which deals with a certain hill. The vertical position or height, elevation of a point on the hill where x and y are the east, west, and north, south coordinates relative to an origin is given by a certain formula, 2xy. There it is. So that's the height in feet of points on the hill. And the origin is placed at the town of South Hadley, Massachusetts. So part A of the question asks, where is the top of the hill? The top of the hill is a local maximum in the function h. We should look for the point where the gradient of h is 0. That would tell us that there is no direction you could walk from that point that would result in an increase in h. Well, the gradient of the function h, in this case we're dealing with 2 dimensions, so dh dx x hat plus dh dy y hat. Let me do those derivatives one by one. Differentiating the function mentioned above, I get the derivative with respect to x as 10 times 2y minus 6x minus 18. And I'm going to set that equal to 0 to find the top of the hill. And I simultaneously need to set dh dy equal to 0, which is equal to 10 times 2x minus 8y plus 28. So I have to solve this system of 2 linear equations, and I think you can take that from here. You get y equals 3, so 3 miles north of South Hadley is the location of the top of the hill, and x equals minus 2, which is 2 miles west of South Hadley. Part B of the question is, how high is the hill? So we'll just evaluate the function h at the position of the top of the hill, and it comes out to be 720, which means 720 feet high. Part C is, how steep is the hill? At the position x equals 1, y equals 1. So 1 mile east and 1 mile north of the origin. We want to find how steep the slope is, and in what direction is the slope steepest. So we need to evaluate the gradient at the point 1, 1 in order to get information about the slope. dh dx, plugging in that point, I got well, you would do 10 times using the derivative calculated a moment ago. You would get minus 220. And as a matter of fact, dH dy comes out to be positive 220. So the gradient of h is minus 220 x hat plus 220 y hat, which refers to feet per mile, change in h with respect to changes in x and y. The magnitude of h would tell us how steep the slope is. It's 220 times the square root of 2 feet per mile, which is 311 feet per mile. And the direction of the gradient is the direction of the most rapid change in h. So you're at the point 1, 1, and the gradient is minus 220, 220, which points in the northwest direction. Northwest would be the uphill direction, and the slope would be 311 feet of rise per mile of horizontal travel.